How's everyone doing? I'm a little late. I get it. All right. All right. You know what I'm going to do to start this off? I'm going to send out a tweet. I'm going to try to be a little bit better about doing that. I feel like it would be a good thing for me to do. So I'm going to do that. Let me get my Twitch stuff up. How's everyone doing today? Sorry I'm a little late. I don't know. I feel like maybe I'm going to not feel well very soon. I'm really tired, and I got to bed at an okay time. So yeah. All right, let's tweet. Simple database indexes, part 2. Live now. How are you doing, Nighthound? How are you doing? You know what? I'm going to give just a little bit of time. I know that there's a few people that were wanting to see this, so I'm going to give them just a little bit of time. And I think I forgot to do something. Doing pretty good. Is school's about to start again for you? You want to see something pretty cool? You want to see something pretty nifty? I'll show you something in just a second. I'll show you something in just a second. Next week? You're pretty excited? All right. You love school. Oh, yeah. So I got K-Pack completely working, Nighthound. I thought you'd appreciate that. I can show you it. It's all working all together now. So later on, we're going to do the database indexes, but later on I can show you the whole system working, which is pretty awesome. Pretty awesome. So I like I said, I don't know. I feel like really tired this morning. Use context. So this is what I was afraid of. I forgot to do the Twitch alerts on the new way of doing the Twitch alerts. So my Twitch alerts are not up. We're going to do the database indexes anyways because I'm going to use some of the recording, so I wouldn't want the alerts on there. I guess it wouldn't really matter. But then we'll fix Twitch alerts right after that. We just have to go get a new token. All right. So this is what we're going to do today is finish our database index. Now, we already did part 1 a couple weeks ago. And part 1, we talked about all of this. If there's somebody new here, let me know and I'll re-go over this. Now, that being said, I'm also going to release this in a video form, like a 20-minute video form, where we'll talk more heavily about the ideas and we'll talk lightly about the code. So if if you miss some of that, you don't have to worry. But yeah, this is what we talked about last week or a couple weeks ago. Okay, so today, basically we got on startup, we built a full index. Now we're doing a hash map index. Now you can do hash map or hash tree. Hash tree is an interesting way of doing it. You can do a hash map, hash tree, but they have some issues that make them a little bit more less used. Actually, I can only think of one database engine that uses a hash map, and that would be the Rake. And the reason is it must all fit in memory, which isn't usually a big deal. A lot of time you want your whole index in memory, but you can't do ranges. So like you can't search query a range. If you do, it literally has to do like combinatorics, which isn't great. You do get constant insert unless if you're rehashing. People don't talk about rehashing in a hash map very often because a lot of times you never get into it, but hash maps do have to get rehashed. And if you're using it as an index where you're putting a lot of stuff into it, it can affect it. Now, how we're doing it this time, this wouldn't actually be a problem for us. So yeah. Another thing is it's still not great if the key doesn't exist. And what I mean by that is if you remember over here, in our thing here, the old way, we'd have to check every file. And in the new way, we still have to check every file's index for if the key exists. This means that you can very easily waste a little bit of time. It's fine. It's not the biggest deal. And these indexes should be a very, very quick because it's actually just a read from a hash map. So inserting into a hash map is where you could get the re-indexing or the rehashing, but reading shouldn't be. It should be a constant time. It's about 9 nanoseconds on my machine. Amount of time wasted for reading an index. So there's a little bit of waste there, especially if you got a really big database, but it's okay. But in other ones, you wouldn't actually have that. In other, B trees or LSM trees. That's actually an interesting topic. So I had always thought the next thing that we would do with this we would implement a B tree. But now I'm kind of thinking that we do all of them, because I have been around B tree implementations, and I'd love your guys' input. I've been around B tree implementations. I've never done one from the ground up. But I have never done an LSM tree implementation. And so I'm thinking, since this is an educational database, we do an LSM tree implementation as like the final one, the final one that we do, because I'd like the experience of playing around with an LSM tree. So a lot of the times the difference between the two is people will say that reading from a B tree is faster and writing to an LSM tree is faster. I think you should take all performance matrix with a grain of salt. But we'll see. In theory, that makes sense that writing to an LSM tree would be faster and reading from a B tree would be faster. But we're talking not that much faster. We're not talking. We're talking theoretical. I don't know in actuality, because in actuality, there's a lot more than our happy little pictures will go into. So anyways, I think maybe that's what we'll do. The next indexing one, we'll do B trees, and then the next one after that, we'll just do LSM trees. We'll do all of them. Instead of, I had just kind of been thinking about skipping LSM trees, but then I was like, no, I really want to do LSM trees. And then I thought that really it would be a shame to skip B trees, because almost every database out there uses B trees. It's by far the most popular. Some of your newer databases use the LSM trees, so might be nice to create them and benchmark them. Yeah, this is where it gets difficult. This is where it gets difficult because, like, without it being distributed, both of them are going to be blazing fast. Where these start to, and I didn't even bring this up with hash maps. It's a good point. What is when you start to have your index on multiple machines, and B trees and LSM trees are different then. But this is starting to be a lot of work. We could do them both at the same, just locally. That would be good. I think that would be like just a really pure, simple thing. At its simplest, which ones are the fastest? Yeah, I think that would be fun. We'll do that. All right. So with all that being said, like I said, if you're new and missed the first one, please ask questions. We can rehash stuff. Yes. Okay, so my video, I was planning on putting common DBs and whatnot in there. So you know what? Let me just make sure I document these that you guys bring in here. Because absolutely. That was already a plan, but we will. So this is another, if you're new here, I want to make these videos the best they can, and I'm leveraging you guys. So you ask your questions or things that you would find interesting in a video and whatnot, and I get to make sure that I put those things in there. For the video, what common databases use what type of index? So we'll probably cover, you know, Postgres, SQLite, Mongo. And I was thinking like a time series database, because I'm pretty sure I don't know how to spell Prometheus. You'd think how much I've used Prometheus, I would know how to spell Prometheus. This word kills me. Define Prometheus. Oh. Define There we go. So Prometheus, I think Prometheus, it's either Prometheus or OpenSearch that uses the LSM trees. I think it's OpenSearch that uses LSM trees. I'll have to do a little bit of investigation. I'm fairly positive OpenSearch uses LSM trees, whether Prometheus does or not. It's a time series database. I don't know what Prometheus uses off the top of my head, but I will include this in the video. Is there a database you would particularly like to know? We should actually also add in a column-oriented database. What you'll get to realize is that how you store your data doesn't affect as much as you might think how you index your database, which I thought was kind of interesting. All right. Ilya and I will try to find Google BigQuery. They're a little bit tight-fisted about some of that type of stuff. Oh, BigQuery uses... Oh, okay. Sorry, I didn't finish the rest of your sentence. I did not realize that Bigtable did. Or BigQuery. So I have LSM trees and SST tables up here. They're really closely related, but they're not the same thing. We're not going to implement both because I consider them the same. They're like siblings. They're not twins. They're definitely not twins. Definitely not identical twins. And you know, it's kind of like, to me, they're kind of like hash maps and hash trees. They're siblings. Like, you can use them the same way if you like. You can do the same things, but they're definitely a little bit different. That's kind of what LSM trees and SS tables are. Okay, cool. So yeah, we'll go into that a little bit. We're going to have this is topics for the video as well. And you know, right now we're doing a hash map. And we'll get into the code in just a second. But in the video, I'm going to briefly touch the difference between a hash map versus a B tree versus a LSM tree, SST tables. And then we're going to focus on a hash map, because what I'd like to do is then the next video focus on B trees, and then in the next video focus on LSM trees / SS tables. So the only database I know, you know, we can search. Let me Google this really quickly. Let me Google it. What databases use hash map? All right, yeah, that's not very effective. Let's see. This is the only one that I know of, like real database that uses a hash map in the back end. Is Rake. And my Google search wasn't very productive. Okay, cool. So again, please, as we're going through this, ask questions, state things that you don't understand or whatnot. So today we did on startup, we built a full index. So we talked about the trade-offs of lazy loading your index versus building it just fully at the startup. Most databases will do this at the startup. I say that I don't know all of the databases off the top of my head, but yes. And on a clean shutdown, a lot of databases will actually try to persist their index if they can. All right, which is another issue with a hash map as a database, because a hash map doesn't really let you persist it to disk very well. Hash map, it's not very good at that. I don't know if you guys have tried. It's not the favoriteest thing of all to do. All right, so what we need to do is we have a log-based database currently. And so we have this compaction. And on compaction, we need to add an index for the new segment. So if you remember in that video, we'll have 2 log segments that are read-only, and we compact them by combining them effectively together, and we have a new log segment that's produced out of that. What we need to do is that new log segment needs to be indexed, and we need to then add that index to the main index of things. Also on compact, when we delete those files, when we delete those places, we need to remove those indexes because they're dead. They can't be used anymore. So we need to remove those indexes from the list of indexes, the index of indexes, basically what we have at this point. And then we need basically, with our log-based database, when the main log gets full, it becomes a segment. We currently don't index that main log anymore, or currently. So when it becomes a segment, it's out unindexed. When it's in memory still, it's indexed by nature because we currently store that in a hash map in memory. So that's kind of how we're doing it. And if you guys like these, make sure to, and I know that you've been along for the ride, but if you do like these and want to stick around, or if you like these and want me to do more, make sure to watch the YouTube video when I release it, and give it a thumbs up. It's a lot of work. Like, you guys are seeing just some of the work that goes into it. So it's a lot of work to make these. So anyways, let's get into the code. I have the code here. Episode 5 indexes. This is where we were. Let's jump into it. All right. So we have our indexes right here. This is part of our NullDB. And we're going to add a few helper functions here just to add and remove indexes. So then we'll use these in just a little bit. Will we put them up here? I'm going to put them down here. Yeah. All right, so this is the thing that holds those indexes in memory. That's what this is. This is, in the future, this will probably be a singleton. I mean, in theory, it is. There's only one of these that exists. We don't use a singleton pattern. I know that's what people were thinking. In the future, we probably will do more of a singleton pattern with like message passing. I think that would be nice. But yeah. So we want to add an index. We're going to need a mutable reference to self, right? That's a mutable reference. And then what we're going to need, we'll need both the new file, so the new segment, and we'll need the index that goes along with it. I don't know what we'll return. Will we return an option index? I don't know off the top of my head. So my thought here is if an index exists for this segment and we're adding a new one for some reason in the future. So if it already exists, should we return the old index? That's what I'm kind of thinking right now. That's what a hash map would do anyways. So I think we'll go with that for right now. This would be, we named it log indexes. Did we call it log indexes? I feel like log indexes. Okay, I get what we're going with. Don't worry about it. Now we want to get it with right because that's what's going to give us a mutable pointer to the data inside. Yeah. I think we panic here, right? If this doesn't work, it means that we've poisoned, and we don't have any way to recover from a poisoned. I don't like that I'm going to do this because I feel like it's not dealing with a problem, but we should never poison our we should never poison our thread. But actually dealing with this or preventing it is much more difficult. Could not obtain. Because this should block if it's waiting. The reason it doesn't, the reason it returns an error is because it's been poisoned. So yeah. Okay. So, and then in that case, once we have the right lock, it becomes easy. Just a log. Let's see. Main index dot insert. Insert should return, an option V. Perfect. So our key is the segment, and our value is the index. And this is going to just return our if there was a index in there, it's going to return. I don't know that we need this today. So I think that there's a couple ways that you could handle this. I think there's a couple ways that you could deal with this for sure. Yeah. Should the database crash? Because I think that's the easy way of dealing with it. Could we recover from it? I think recovering would mostly be like you could recover from it, especially if you had like a singleton pattern where you could just fail everything other than that and start everything back up. But that's just like crashing and having something else restart the process. So like, yeah, I don't know. I think you're probably right that this is just an error state. You can do better than panicking on error state, you can like log as much as you can, because like we don't actually have to die here. We're choosing to just kill it, but we could, you know, take a whatever of our memory, you know, a snapshot of our memory and a bunch of other stuff that we could do instead of just panicking. But yeah, yeah. All right, I screwed something up here. Let's see. Mismatch closing delimiter. Let's see. Let okay mutable main index equals this dot right else. This looks fine. It's fine. Oh, what is it? Did I... Wait, why is it saying mismatch? Do I have an extra curly brace somewhere? I believe I have an extra curly brace somewhere. Where's the extra curly brace? Oh, it's not a curly brace. Ah, thank you. Thank you. Okay. Thank you. Thank you. I don't know why I was not seeing that one. All right, so then we need to do basically the same thing for remove, except we'll just move. We need to get a write to the main index, but instead of insert here, actually two things. We don't need the data of the index. And here we just call a nice function called remove. We'll just take a string reference, right? That will be good. Yeah. All right. These are going to help us with on compact add index. So basically, we're going to need to be able to call these with new information. So that's why I'm doing these. All right. So let's start looking at creating the log segment. Now, I think there's a little bit of cleanup we can do for the video for this. So I'd like to do some of that. When I was reviewing some of this, I was looking at, let's see, there's our index.mod here. I was looking at this and there's a couple things. One of this is actually going to help us, and we're going to do this right here. This part here is really the part about creating the index. And since we need to do this on our new segment files, this would be good. Now, in theory, the most efficient way would be to build the index as we're inserting stuff into it. But that would be more work. And so we're going to do it kind of the lazy way. Both ways work. It's a trade-off of efficiency, and we're plenty efficient. So we're just going to put a new helper function in here. I almost did a new fun function. Let's see. We're going to, what are we going to call this? We'll just call it something like, okay, so this is generating indexes for the entire database. on startup, but we want for the individual file. So we're going to do generate. This should be public though. Pub fun. I don't know why I'm typing fun. I have a friend who loves the Java clone Kotlin, and they type fun, and he's always talking about how it's more fun, so it's poisoned me. For and generate index for segment, a little verbose, but we love it. So we need the path to a segment. It's going to be a string, and this is going to generate us an index. Maybe an optional index, maybe. Let's just copy and paste this stuff up here. Put that in there. Uh-oh. That is not at all what I needed. Let's see. How many should we guess? I'm going to guess 3. Nailed it. Nailed it. All right. So we have our segment path. We don't need this. This is us. Yeah, we don't need this. The path is getting handled into us. So we can delete this. This is just us verifying that it's not the main log, which we won't have in this function. This is just a plain function. We're creating a new index. We're reading the file, so we'll just do segment path, done. Okay. We read the file, we get the line numbers, we go through the lines, inserting into it, and we return this. All right. We don't return this. That doesn't return itself. We just return index. Okay. Oh, we don't need this at all. We don't need this at all. We delete this. We delete that. That's what we do. This is us. This is our index of indexes. That's what this index is. All right, so let's delete this stuff. And then this goes down to let index. Actually, this always returns an index. It's not an optional. Let's just do this the right way. And let's just do generate index for segment, and then our segment is going to be our path. Just like that. Yes, Mom. Actually, instead of clone, we could just take a reference here, right? And we'll just borrow it here. That way, you know what? I'm going to go with just cloning and not doing this. Consider cloning the value of the performance. I am cloning the value. Oh, it's also talking about here. Question. Should I do it like this, or should I do it like this? This would be the more performant way. It doesn't matter. We're not building we're building a blazing fast, not a ludicrously fast database. But I don't want it to be confusing. I don't want people to get hung up on the Rust. That's not the point here. I'm writing it in Rust because I like to write Rust, and since this is a pet project, I'm writing it in Rust. And like in theory, there's actually lifetimes. The compiler can just guess the lifetimes. I'm going to just do the clone, I think. We only need to clone it once because it was getting consumed here. Blah, blah, blah. It can get owned here. That's fine. We don't use it again. I'm going to just leave it like this. I want to, yeah, make it as simple as possible. Maybe I should have written it in something other than Rust. It feels wrong though, because like, as far as I know, in a database, you write it in C, Zig, or Rust. I don't know. There's some others, but performance is always an issue. Postgres is in C++. I say C++, but it's like a very limited form of C++. Yeah. I think clone here is like the right path because this is very little. It's just the thing, and I just want to keep it simple for people. All right. So we now have this moved out, which is going to be easy because now when we have a new segment file that we're doing, we can just use this to generate that for us. Cool. I need to comment a little bit better. Actually, all that looks pretty self-explanatory. I want to make sure that I'm commenting this a little bit better. So if people want to look at the code, as I encourage them to do, they can. All right. So let's go back to the NullDB. Where do we... Here's our file compactor. So this is where we can start compacting, right? I haven't been in this piece of code for a little bit. Not the best. This probably needs some cleanup as well. Because like I know this is copied from another section. It's copied, but there's a reason it's not in a function because it's difficult. We do extra things in there. All right, so this is where we delete the old logs. When we delete the old logs, this is where we also need to remove them from the log files. So we can do that. We have the database here. We have a reference to it. Right. Where is that? Oh my gosh, this is a terrible function. This does need cleaned up. All right. Yeah, it's just the DB. All right. Oh my gosh. So here we need something like db dot we need to call write to it. No, not write value to log. We need to what was the thing that we wrote on it? It was add index or remove index. And this would just be the file. Cannot borrow data in arc as mutable trait. Yeah, this is where we need like dot autocorrect wasn't getting that for me, the right. So I'm feeling like I'm missing something. I went down, not up. I feel like I'm missing something here. Okay, wait. We have the NullDB inside of a data. Ooh, what is this data? I don't remember that. Oh, This data wraps an arc. Got it. Okay. Okay. So how do I get, do I need to, oh boy, do I need to, I don't think I have mutated the database from the background thread yet. So I need to think about this. I didn't think about this before this stream. We're passing back this compactor. I might need to pass this a little differently. Because I don't think this is going to allow me to dereference it as mutable. That's a shame. This is going to be a little bit more work. All right, let's go to the main log here where we build this up. We have our main database here. I hate threading. Let me think about this. Really, this should be a message, right? Really, this should be a message. We should do that. This should just be a channel. So if we do that, we're going to consume a thread here listening for that, right? Right now, this kind of reacts to things. It's kind of a reactive. Ooh, wait a second. This is... Oh, okay. I'm going to do something. You guys can hate me for it. We're not going to do all that work. We're not going to do all that work, are we? No, we don't like work. Now, you guys might be asking why this is working and not complaining. And this is working and not complaining. And we're not taking a mutable reference to self because everything we have in this thing is thread safe. Everything here is thread safe, which maybe it doesn't need to be, but we're getting the locks for those things anyhow. So we don't need a mutable reference, even though we're mutating. Now, this is a little gross because it kind of bypasses Rust's stuff here. Right? Like, now it's a little gross. I'm not going to lie. But this now works. I like this. I like this so much. This is where I was saying we really should move to a single 10 where we have that one thread writing and we just pass messages to it like, hey, new value, or get to this value for me. I'm going to leave this for right now, and then maybe we can move to that. All right. So, hate it or love it, we've now done this. Probably you should hate it. You should hate it. I mean, like, it is still fine and safe. Rust is protecting you. You don't need a mutable reference to do what we've done because the things themselves are wrapped. But it means that you don't have a mutable reference here. And I think the bigger problem here is while it's safe, while the compiler doesn't have a problem, one of the things I like about mutable is being explicit with your desire to mutate an object. And we're not explicit here with our desire to mutate this object. And yet we are. All of these functions are mutating without being explicit that we're mutating. Now, I think add an index, remove index, they're kind of self-explanatory that they're mutating an object. And one of the problems is you're really mutating stuff on disk a lot of the times with these. So like that's actually what's gotten us in the trouble in the first place was we had like write a thing, and that's not mutating anything in the application. It's mutating something that we own outside of the application. Gross. Okay. Moving on with Bad Rust 101. If this is it, we need to also, let's see. This is the file, create a new file. We need to let new segment name equals format. This feels like it should be in a function somewhere, not hard-coded. Oh, well. This is our file gen and our since the epoch. Also, we don't need format. That was not thinking. New segment name. All right, cool. Awesome. Okay. So we're going to write that file. As soon as we do, we need to create an index for it, which we now have in our utilities. Do we have our utils here? Yes, we do. Get all files, create next segment file. Wait a second, this is not the right utils. We wanted index, probably, right? I think. Let me see. Index.mod. Yeah, we want this. Generate index for segment. So let's go back. Let's go up all the way here. Use do this. Use super index. All right, back here. We're going to generate index for segment. The segment path is going to be new segment name. Done. And then we need to db.add index. I'm a dum-dum. Let index equal this. And then this is our new segment name. Yep. We'll just clone. No need to do this efficiently. It's super small clone anyways. It doesn't matter. Borrowed move value, new segment name. It was already borrowed. Clone that here. Done. All right. We still have more to do though. Let's just copy these two lines though. Those are going to be pretty common. So up here, this is where we create the new file. So we're going to paste this here. I'm guessing 3 again. Oh, beautiful. Beautiful. All right. So we have our index. We'll generate it. We need this file. I'm starting to feel like at least with this, I'm going to make a little function here. Called generate segment file name. And this, I think, is going to take in just the file gen. This is the generation. What is that? What type is this? Duration. It's a duration. Good. And this will return a string, a happy little string. It's a happy little string. Okay, so let's just, we'll take that. We'll take that. We're gonna throw that in here, and then we can just take this and return this. Let's see. Why are you upset? One second. I don't understand. Let's see. Time duration does not implement display. Okay, that's fine. That's why I have the colon question mark, right? Wait. Why did I put this as duration? I'm just not thinking well this morning. This is just an int. This is just an int. My bad. 32. My bad. The generation is just a I32. All right. Whew. Not sure why that. Now we can go and clean some of this up. Let's see. Where was I doing that? Here's the new segment name. So instead of this, let's do what? Control V, Shift $, D, I space, generate segment name, segment file name, and we need to do the file gen. Beautiful. That's so much better. So much better. All right. We're going to do that again here. We're going to do that here. And then let index generate index for segment. New segment name. New segment name. All right. Yeah. Cool. This is nice. And then we don't even use this. We don't need it. Nice. All right. Beautiful. Is this all making sense at this point? Any questions? Anything you'd like to see in the video? Besides beautiful animations? Look, I've been working on the beautiful animations, but don't hold your breath for them, okay? Don't hold your breath. All right, I think off stream, I'm going to do some cleanup of this function. This is pretty rough. It's very rough. Very rough. I'm gonna have to clean that up some. All right. It was telling me it was unused. That's why I deleted it. Okay. I thought I had another derelict unused thing. Okay, whatever. All right, so now we add an index when we create a new file in the two places that we create a new file. And at the point where we clean up all the compacted files, we remove the indexes from this. This will also be safe on a restart, because on a restart, we clean up or we build all the indexes new. So let's do this. On compact, add index for new segment. Yes. On compact, delete index for new segments. Yes. On new log, index new segment. This is what we haven't done yet. Yeah, the visualizations. So the visualizations will be there. They're not going to be, I don't have a graphic designer. I can't pay one to do it. So like, they're going to be what I can do. So hopefully they'll explain the information. I'd love the feedback. I might actually share some of the visualizations in Discord to get some feedback from you guys. Actually, I will. I'm going to share some visualizations in there to get some of the feedback. Yeah. So next week, I'll throw some in the Discord for you all to critique. If you're going to say that I could make them prettier, yeah, you're right. That's not going to happen, but you're right. I'm looking for, like, does it help people understand? Yeah, actually, some of them are going to be this. Like I'm taking a picture, I'm drawing some stuff out with this, and then like in the animation software, it's easy to cover something up and then like basically unhide it with a mask. That's super simple. So I'm taking some of the like these drawn pictures. So it's not like a real animation, but it looks like a kind of an animation. It looks kind of like an animation. So, but I like, what I really like is to make sure that, it explains the topic fairly well, or at least helps as a visual aid, more than if it's like really pretty. I would love to get pretty pictures at some point, but I will make do. All right. Last thing that we needed to do here was, so what we haven't done is this. When we have the main log we know we keep in memory right now. That was the last episode. We keep it in memory and on disk. And that saves us a lot of things. But what we need to do is when it goes out of memory, when we, I'm going to say flush to disk, even though it's still in disk. When we flush to disk, we need to make an index of the stuff that's on disk and add that to our thing. So we already have the functions. This should be pretty easy. We just need to jump over to the NullDB here. And basically on write, that is not, okay, let's clean some of this up. We have extra spaces here. Don't need that. Nice. All right. Write value to log. So this is when we're going to check. This is where we're checking if we have filled up our log. Right now, it's literally a line count. I understand this is a magic number, but let's add a comment here. We actually don't need to print the line count. All right. Check if main log is full. Again, right now it's an arbitrary number. There's very much tweaking that you can do on this. Even to most databases let you tweak this yourself if you want to optimize for your data, for your workload, for your stuff. And then there's usually pros and cons. I just pick 64. It's an arbitrary number. It's not even a setting. It's just hard-coded. It's just hard-coded. Okay, so we get a new log, a main log file. And we create the next segment file and make that the main log. What we need to do here is take this main log and create an index for it. So index. I'm sorry, I've been writing a little bit of Go. All right, let index equals self dot. Oh no, I need to create the index first. So let's do that. That's index dot generate index for segment on the main log. This will be safe here because we have a write, so nothing else can be writing. So even if there was a new request to write, this would be blocked. So this would be blocked right now and waiting. So this should be safe. Need something, bud? Unplug it. Unplug it. Oh, okay. 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 Sorry about that. Okay, so we'll generate our new segment for the log file, and then we're going to also go ahead and write that. Add index. And we're going to add... We're going to add something here, right? Okay, which one are we going to add here? We're adding the main log, because it's still the main log as of this point, and the index right here. So that's what we're going to do. Cannot sign. Okay, try to... Oh, toString. Sure. Try using a conversion method to string the main log again. That's fine. Cool. All right. Because this is... It is a string. So, yeah, cool. That should be fine. Wait a second. Yeah, I do reference it here. So this should be a string. Okay, cool. Should we try, let's see, next error. We have some errors. Why is this not used? Oh, it's just the mutable part isn't used. Okay. Do we really not use that? Do we? Kind of felt like we did, but you know what? I guess... There we go. Clean that up. Perfect. Should we try running this? Oh boy. I feel like I've got to have broken something in another file. Here we go. Cargo run. Okay, so that's I need to do some cleanup. That's okay, that's too much for a video. I allow some things here. I don't make it perfect. Well, for some of this, like, this is not actually, yeah, this is in the file reader. I don't touch the file reader. But I do have an unused import. That's easy enough to clean up. Yeah, all of this is the easy reader stuff in the file reader. Which it's saying these things were never used because they're not used, because it's a library that I'm using, but I had to pull in their code because I had to make a modification to it. So like, they're not wrong, but it's also not really my code. So I'm not going to go in there and touch, it's this. So this was from Easy Reader, but I had to modify their code to just a little for what I needed to do. So that's kind of the dumb part there, is like, yeah, it's saying these things aren't used because they're not, but I'm not going to go through and delete all those things. Maybe I should. I don't need them or use them. Maybe I should just go through and delete them. All right. Cool. We can actually... let's go over here, create a new terminal. We have a CLI. Cargo run. Do I remember my CLI? I don't believe I do. I don't believe that I do. All right, cool. So we can do add. Let's do our add here, our put. Merrick is here. So we're writing to the database. Cool, cool, cool. This should be done. All right, how do we prove our indexes? And that we're actually leveraging our indexes. I mean, we can look at the code. We can look at the code here and, you know, make judgments that, yes, it uses an index to read. But how do we test that? How do we write a test that proves that? This is going to be interesting. Maybe we take this on in another stream. Thank you, Lion Lord. Probably not Lion Lord. Probably not. But you know what? That's what I'm going to call you. My Twitch alerts, that's what we're going to work on next, is why my Twitch alerts are down. They've been down because I just need to revamp the key that they talk to Twitch with. So I need to update that. Should be really simple, but I have some pretty awesome Twitch alerts that we made here on the stream. Lionel Lord? That's what I'm going with. Anyways. Welcome. And sorry my Twitch alerts are down. I blame the stupid piece of hardware that keeps failing. Yes, that's what I blame. All right. All right, how do we prove that we use this index? That we use let's go where we read. Let's go where we read. This function needs help. This get value for key is, I'm not even actually sure. Like, have we just built our, do we not read? Do we not use it for reading? Yeah, no, we're checking. So we check the index. If it's not in the index, let's see. So yeah, basically this is where if it's not in the index, we move on. And then here we get the value for the segment with the line number. So this is what we did last time. So how do we prove this though? So in my video, one thing that I would like to do is prove that we're using the index. In theory, we should. So Lionel Lord, I'm writing really simple Rust here. We actually were having a conversation and I called clone to keep it simple. We're not doing advanced anything, so you should be able to follow along, hopefully, for the most part. But yeah, feel free to ask questions if you have them. But yes, I do. I actually have a new Rust video coming out probably this weekend. It's been too long. It's just sat there because I've had other things to do. All right. The dirty way is to log in and check the console. To unit test it, you need to emit something. Yeah, that's what I was thinking. Like, the other thing I was thinking is in the CLI, I have this benchmarking tool. So we can do bench here. You can just do bench, and it will write a lot of stuff. It will write a ton of stuff to the database. And writing isn't going to be any faster. Like it's going to take the same amount of time to write. Actually, it could take a little longer because technically we're inserting into an index, we're building a new index. So like this is actually a little bit longer. So, you know, I think last time we were doing like 5 records per millisecond instead of 4.5. So like we lost like a half a millisecond on writing. Or half a record on writing per millisecond. But what it should do, and I don't have one to do this, we could do a reverse bench where basically we then test reading values, like random values, and seeing how much faster. Let's try to do that. Now, what I need to do is I need to do the benchmarking. I need to do that bench on the old database as well. I need to do that on the old database as well. Ooh, index misses. So index misses that you're talking about are a little different than this index. So you're talking about like index misses in a real database. We're not to B trees yet, which is... I mean, you can't have an index miss on this, right? Because all the data is indexed. So the only index misses we would have is when you don't have a value, right? Because in something like in something like SQL, what's going to happen is you're going to have your index. So this is going to be your data. And there's in SQL, it's easy. It's a row based. So you're going to have your rows of data. And basically what happens is when you have an index miss here on this, 1 second. I don't know why I'm enjoying this. It's like a game. Oh, went too fast. I was getting a little crazy. All right. So your index basically allows you to go through this, but you index a single thing on here, and it allows you to jump through that. But what an index miss is going to be is when the things that the way that you were querying that data wasn't indexed. So that could be like you used a secondary index that wasn't part of the index or something like that with your join or whatnot. And that means that it had to do a full table scan where it went through each row looking for the things, which is what you're trying to avoid is those table scans. I don't have that at this state because we have this, but every single line is indexed at this point because we only have a key value store. So there isn't different parts of the value. Emit the index hit. Okay, I like it. I like it. Index hit. So what we need to do is emit a index hit, which segment file and what line number it was, right? That would be good. We have those two things right here. Is if it's gotten here, we'll just do a print line. We should do a logging though. We should definitely do some logging through this. We'll do record found file. And this will actually let us go through, find the file, and validate that it's doing the right thing. I like good thinking, Russell. File, we'll do the file, and then line number is the line number. So path.clone line number. All right. That should give us on Git, it should find us a file. I should wrap it in a debug. Yeah. Is there I have never done like a Rust debug, like is there like a macro for that? Or do I need to like make a debug thing? I feel like there should be a debug thing where it just removes it completely. I've never done that. We'll have to look that up. We'll look that up in just a second. I want to actually see this run. What we'll do is we'll just do a put. Merrick is here. We're going to look for Merrick. But what we'll do is we'll make it compact it first. So that's going to get compacted into a couple generations ago. And then we can go find the file. Actually, this will be a good test to see if we haven't screwed something up. Because this should get is here. Yes, I was actually a little nervous about that because if we actually like indexed off, it would have pulled back the wrong record. Like if the line numbers were wrong. All right, so wait a second though. We did not see. Did I not save this? Did I not save this? I did. Did I not restart this? Oh, return value from the main log. It hasn't gotten compacted yet. Okay. Okay. You know what? The one problem with my bench function, we can look at the segments. It's not going to pass our 64 because it just uses the alphabet. With just using the alphabet, single alphabet, it's never going to compact. Okay. That's our problem. So it's always finding it in the main log if you do this. It's getting it from the main log. So how do we cause this to compact? Well, we would fix our CLI. That would be one way. We can just put a couple things in here though. What is this log used for? So what is a log used for? This is a also MetaMe. That's what I'm going to call you. Sorry, my Twitch alerts aren't working. Doing this first. Thank you for the follow. I appreciate it. And then we'll get the Twitch alerts working again in just a second. We're learning about databases. So this is a log-based database. I have some YouTube videos. They're linked in my profile here. You go check them out. So I wanted to help people that wanted to learn and understand what databases are, to understand how they work. So this is a log-based database, which basically means our data is based on a log. So this is not a log in the terms of like a diary or something like that. It's actually how we're managing data in the back end. That's the log that we're talking about. Now, there's many other ways to manage your data in the back end. And honestly, this is going to mutate to not a log-based database in the future when it's going to be like a log adjacent database in the end. Right now, it's a pure log based database. In the future, it's going to be a log adjacent because we would love to have multiple writing threads at the same time. And to have that, you kind of make it a log adjacent database. So right now it's a pure log-based database. So each entry is a new log in the diary, and it's read-only. But I did make some videos on them. Go watch them. Hopefully this next one's going to be even better than those. I put more work into it than those, the first one. So. All right, we are not flushing this out of the main log, but that is concerning to me. I feel like we've screwed something up, like I thought. I feel like we've screwed something up. So if you look at it, there are files getting compacted. But it keeps saying that it gets it from the main log. Let's see. Value from return value from the main log. So it is getting it from the main log. Are we just not flushing the main log? Is that what's happening here? Because when it makes one of these, it should flush the main log. We actually worked on this. So like, while reading, we don't check that. Let's write value to log. This is where it would be. So if the main log is full, that's what we're not doing right here. I think this is a bug since last episode. When we changed to an in-memory one, we don't flush the in-memory log or the in-memory values. So we're just filling up memory at this point. We could actually test that. We have 12 gigs in memory. Let's just run some benches here. Actually, a gig of text is quite a bit, though. This would probably take quite a bit to... Like, this is probably destroying my file system more than it is going to add... I don't know. How much is a gig of text? A gig of text is quite a bit. Let's not do that. Let's not actually prove that. I think it's fine. I think it's fine. Okay, so here we need to... We've indexed it. We've added the index. It's already written to disk. And so now what we need to do is clear it. Clear it. Let me think about this. Let me think about this. We're going to have to just basically do this. I'm going to just copy this. This will need cleaned up some. This will need cleaned up some. So instead of reading a value, we're going to get our main log. And then here, we just need to clean up our log. Main log dot get, not get. We need to main log dot, we want to empty it. Do we just reassign it to a new one? Is there even like a clears the map, removing all key value pairs, keeps allocated memory for reuse? I don't know what's better, to call clear. Yeah. I think doing Valgrid for memory leaks would be awesome. We should do that. We shouldn't make it part of the database video. Like, we should, like that, and maybe I make a video on it if we find some cool data leaks or something, memory leaks. That would be awesome. And maybe video worthy, but maybe also not. That's not what this video is about. Can we just do main log.clear? Wait, why is this complaining? Why is this was here all along? Why is this complaining now? Oh, we're shadowing. We're shadowing here. My bad. Main log, main memory log. All right. Okay. Cool. We need to put mute in here. No, cannot borrow data in dereference. Read write lock guard. Oh, I'm reading as read. That's why. This is protecting us because we only borrowed it as read, so we can't write it. Oh no, what did I press? What did I press? Go back. Go back. I don't know what I pressed. All right, so this only has it as read. So we want write. There we go. Okay, cool. Beautiful. You think there's a memory leak on screen right now? Which line? Point it to me. Point it to me. There probably is at least 2. I'm guessing 2 memory leaks on screen. I don't see them though. I choose not to see memory leaks. Oh, okay. You're talking about, yes. I was being bad there. Okay, so this might fix our problem. You've used Miri and Val. Okay, which one do you prefer? I'm probably not going to do it today, but maybe next Saturday we'll do a Rust memory leak detection thing. Maybe I'll even write some code between now and then that actually leaks memory. Maybe we make like a little video on, I have a Rust thing, and I could do one on detecting memory leaks and like patterns you can do to actually leak. People think that you can't leak memory in Rust, and I'm like, any language you can leak memory. Trust me, been there, done that. I don't think they've made a language that's safe for me yet. All right, next weekend we'll at least do a half-hour Rust memory leak detection. I say at least because, if we have a bunch of stuff here to go over, we'll go over it. But if not, I'll make at least an hour of content, or at least a half an hour of stuff of like, hey, here's the 2 tools, how to use it. Oh, true. Hey, if you made a video, put a link to it, as long as it's, at least PG-13 or less. Throw a link in the chat. Let people see it. My videos are also not high production quality, so you're in good company. You're in good company. All right, before we run this, let's delete some of these null segments. Let's clean up this database. Oh my gosh. rm star dot null segment. Cool. I will watch that before next week. I have used Val once, Valgrid once. So I also have not had a ton of experience with it. Cool. Clean that up. Now any files that are there should be our own. Let's cool. These are our test segments. Cool. And this is our new segment. You always make a new main segment. So if we add a value, we should see a value in this segment. Or not, you know. Oh, I said get, not put. All right. Now we've put a file there. Now we should see Bob is here. Cool. All right. So now let's do, let's put Merrick. Merrick's an easy key to remember. And now let's do some benching to get a couple things there. No, MetaMe, I appreciate it. I absolutely said to, because if you had, I would have been annoyed. But you didn't, so that's I'm not competitive though. If somebody's making awesome content people could learn from, I want to help share it. All right, so we have a bunch of log files. Bob shouldn't be in the main log file. Neither should Merrick. Let's check the main log file. We don't know what the main log. That's kind of one of the key things. We don't know, but it shouldn't be in the main log. So if we go here and get Merrick, there be a bug. All right. We had an index miss. Now, where in the index is it missing? I don't know. Cool. So let's jump in here and see. All right, so let's walk through this. All right, so if it's not in here, check for it here. Okay. And now we're going to put some logging in here. My guess is we screwed something up with these indexes. So these indexes, my guess is we screwed something up with the indexes. This would be my guess since we just did the indexes. So it went through all the indexes and didn't find a match. All right, you know what we're going to do? We're going to stop this. We're going to delete all of them. We want just a few segments. We're going to make this a little simpler. I don't know what theme this is. It's a good question. It's just whatever theme was there. I'm not nearly good enough at Vim to have a theme. So, yeah, I'm not nearly good enough. I am a Vim noob. I have just started learning Vim. I write it mostly on the weekends. So, I suck at Vim. How are we going to figure out why it doesn't have... We either are checking the index wrong. We are literally just getting index misses. Let's simplify this. We're going to write values when line count is 5. We're going to keep our segments really small. We're going to do that. And then what we're going to do is we're going to emit the data on index creation. So on startup, let's jump in there where we create all the indexes for everything, and we're gonna print out everything for all the indexes. So let's look at on startup here. You used Emacs for 5 years? Yeah, no, I used VS Code for 5 years. So I'm like in a worse position. I feel like a person that comes from Emacs at least has the general idea, the general concept, but okay, so we were looking at where we create our index up here. So the only thing that could fail here is generating this index here where we pass in the main log. So in our generation, we want to print, let's just do like a quick, oh gosh, what did I do? Oh, we just want to do, let's do a really quick and dirty, yeah, that's why I'm a weekend Vim warrior. I'm getting where I'm close to productivity. I think I'm close. I was never a fast VS coder, but let's see. Indexed. Let's see. We indexed that file. Do we want to index? Do we want to write here just what file we're indexing, or do we really want to index or print here for each line we're indexing? I feel like we kind of want to do this. What is Rust going to do if we print out this index? I'm going to try that. I don't know that it's going to work. Let's do the colon question mark. It's got to be at least a colon question mark. Let's we'll do file and then index let's see, segment file path. We'll need a clone on that bad boy, and we'll need a and if you need, let's see, and then we'll just drop the index in here, right? Okay, we need to clone it up here too. That's fine. All right. That seems to work, so let's do that. So now what we can do is we can just put a few things here. Merrick is here, then we're going to fill it up with a key called Bob. We should see a compaction here soon. There we go. This is wrong. This is wrong, right? No, this is right. This is right. Okay, this is right. because it was the last Bob is here, and we didn't compact it. I was thinking it was wrong because it should compact all the Bobs, but this is not a compaction. This is a writing of the segment for that file. So if we look at this file, yeah, the last one is here. So 0, 1, 2, 3, 4, 5. That looks right. That looks right. Uh, 647, and this is 647. Okay, so the index that we built looks correct. And then we have a new log segment for our latest Bob one that went over our 5 lines, which is actually 6 lines because it's 0 indexed, and I'm just looking at the index, not the actual number of the lines. But like I said, it doesn't matter. It's an arbitrary number. It's to keep your log segments small. So yeah. Okay, so we have proved that our database index is being written as we would expect, but if we now go here and query for Merrick, get Merrick, it's going to say value not found. So now we want to, in this really simple form, we want to basically, I guess we're going to search out the whole index. Every single miss, we want to print out what the index looked like. So let's get value. Wait. What file are we in? Oh, we're in the generate. Okay. We want to jump over to the NullDB. And we want to go to get value for key. Here we are. And then on here, I think what we'll do is we'll just print every index that we check. Check the index for the value. So we have the index, and we're just going to print it. Do we just do it in here? I think we'll just do it in here. Index, value not found in index, or key, not value, key not found in how's everybody doing today? How are we all doing? Hope everybody's having as good of a possible day as you can. I am good, IASC Boxy. You just finished work? Was it a good day? Is it Saturday for you? So we have our key, and then we'll just index. Cool. All right, so for each miss, we should print something. And since we have a small database, it should be not catastrophic, the amount we print here. So this is us indexing. So basically the indexes just have 2 things, which this does make sense here because remember, we don't index repeated values, or shouldn't. Like, we're just the real values. This file, this is maybe an interesting point to point out. This file doesn't know that Bob is actually in a newer index, because that's not the index of the job. It's just, this index should say, in my file, where is Bob? Where's the newest version of Bob in my file, not in the rest of them. So yeah, we could make this aware that there's another Bob. That just add more complexity, though. Isn't really needed. So this looks correct to me. Now let's do get. Let's do a get. Let's get Merrick. All right. Key Merrick not found in index. Oh my gosh, this is wrong. The key has the value in it. I'm such an idiot. I'm such an idiot. I've been looking at this being like, oh yeah, this looks correct. No, this should just be the key, Merrick. Of course, Merrick is here does not match Merrick. Oh, that's been staring me in the face. Oh. Well, welcome, IS Boyix. Boyix. I'm going to call you Boyix from now on. I don't know if that's how you pronounce it. That is how I'm pronouncing, which is the official way to pronounce it. Just joking. I have no idea. Only X for friends. All right. Let's see. That's in our generation of indexes. So let's look at index here. We have screwed up. I'm going to blame you guys for this. Oh, we don't parse it here. We take each line. That's why. If you remember right, we don't have a data format yet. So we don't have a data format. Our format is literally just on like just a semicolon. So we need to actually parse this. And we actually made a data structure to parse this, which I don't remember what it is. So we need to go look that up. We have a slick way of parsing this. Get value from segment. This right here. All right. Well, thank you so much, ICS Boyx, for the follow. I appreciate it. Sorry, my Twitch alerts are broken. We will fix them. We will. It's on the docket. All right. Let's see. We need to go back into index here. And we need to actually parse this. This is a travesty. All right, parsed value equals, was this not indexed, tabbed correctly? Let's see. That's weird. All right. No, this should be line. Value doesn't exist. Line. Got to resolve use of undeclared crate or module utils. Okay, let's import it. Can I tell it to import it from here? I know if I do this, utils, it will like, I can import it that way. There we go. The question operator can only be used in a, we don't return a result. This does return, this has a possibility. Basically, corrupt data is what could ensue from this. Oh, this actually parses out a tombstone too. Oh, interesting, interesting, interesting. How do we want to deal with that in our index? I haven't thought about this. How do we want to deal with tombstones in our index? So if it's tombstoned, it's deleted. I'm going to just say that we put it in there. Although this is going to return an error. No, I guess we won't put it in there. I think that's probably the fair thing. We don't need it. We don't want to check for it. If we're checking the index, we're checking valid values, and this is not about... Never mind. I don't know. That's a ridiculous statement to make. Ridiculous statement. We want to just follow with this. So we'll just update this to this. We'll do if let okay parsed value equals this, and then we'll just throw this in here. We'll slap that up there. Done. And then instead of this being a line, we don't want to insert line. We want to insert parsed value. Wait a second. Is this getting the... This is getting the value, though. We don't want that. This is getting the value. We want the key. Do we have a function for just parsing this? I'm going to do this. We're going to make a new function. Get key from database line. So we're going to keep this check in it because we don't want tombstones. But what we're going to do is do this. Let's see. We're going to do it 0. It's kind of dirty. Kind of dirty. Okay, so... we don't need to check this for a value. We're just going to return whatever this key is. All right. I think that's beautiful. I think that's beautiful. Pure genius. I think there's a better way to handle all of that. Look at that. Oh my goodness. It's like... And the record was found now. The record was found because I'm not an idiot. Awesome, awesome, awesome. Merrick was not found in the main index. The Merrick was not found in the second index, in the second segment. Now, if you remember right, we blindly create a new main log every single time we start the database. That's why we have this empty main log right now. Instead of just reusing this one, it's fine. That's actually how we intended to do it. All right. So that looks like it's working. Let's make it a little bit worse. Let's put our newest follower in here. Let's do that. Okay, let's put our newest follower in here. ICS Boxy. No, Boix. Boix. I don't know what Boix means. Hopefully it's nothing horrible in a different language. I was trying to use Vim commands. That's not what I meant to do at all. Newest follower. See, this could be you if it was you following. Oh, you're a boy from the X generation? Okay, I get it. I get it. I don't know what generation I'm in. I never followed the generation that I was assigned to, I don't think. All right, so let's bench that. Let's get it purged. We purged it well out of. That's like a. I feel like there's an accent that would pronounce purge, like purged. I purged it. Anyways, not making fun of anybody. Just maybe myself. So this is cool. So these are the keys for each index, and this is the line number that it's at. So I is at 2, P is at 3, J is at 0. Not the values. There are no values in that. The index doesn't have the value. Okay, cool. Okay, now we should be able to get our newest follower. Could have been you. Could have been you. And we're going to see it have all the index misses. Cool. Oh, wait, did I misspell it? Oh, I did. I looked for ISC. Is it ISC? No, it's ICS. Well, see? It wasn't found. ICS. There we go. Which is our newest follower. And we can see the whole index search. This is each segment. I broke the segments into 5 values. And we can see that. And we see it. Cool. Nice. All right. I'll have to think of a nice way of doing this for the video. The other thing we can look here is our generations. Oh, I don't have compaction on. So the next thing that we can test is that this survives a compaction. I don't run it in this mode with compaction because it hurts, because it starts moving stuff around on you in the background. And so if you want to go validate something, it's almost impossible to validate. I mean, it's not almost impossible. It's just much more painful because stuff gets compacted away all the time. Which it means it's doing its job. It's just moving stuff, like the files change on you. We're going to remove all those. And now we need to run this, but... do I have help? How do I run it with compaction? I need to look in the code. I need to look in the code how to turn compaction on. Yeah, there we go. I think it's just run with C true. No? Oh, it's just with C. Done. Okay, so now compaction is running. And what we want to do is we want to make sure that our indexes survive compaction. So we're going to put we deleted our whole database. So we're going to put our newest follower in there. And then we're going to run some benches just to fill it up with data to get the compaction going. We want to encourage compaction. And now we wait. Will this database ever be multi-node? And the answer is hopefully, because that's part of a database, is that you actually have to be a real distributed app. A lot of times people think of distributed app. We're going to wait for this compaction to happen because it's on a timer by default. A lot of people think that, like they have a distributed application because they use a database and they have like microservices that are stateless, which is fine. And it's good architecture. Have nothing against it. But the real distributed applications are ones that actually have to work as a... So the answer is yes. The answer is yes that... oh, you know what? I forgot. We actually have a command to force a compaction, so we should just do that. We should just force a compaction. I believe... let's do help, but I think it's just compact. Yeah, it's just compact. Okay, we'll do that. Just force our compaction here. But the whole point would be that we're going to learn how databases work. And one of the things is that it is going to be multi-node. Now, it's not going to be multi-node with the index that we currently have. We have some things to do to make it more multi-node. And so if you're going to say this year, no, it's not going to be this year that we start to make an actual distributed database. And it's always going to be a simple distributed database. My goal isn't to make this a production database. My goal is to make this a tool for people to learn with. Yeah. All right, so we forced compaction. Oh, that's really awesome, Define Evil. Well, if your company ever wants to sponsor a video about databases, you know some videos that are getting made that are pretty fantastic that just teach core things about databases. And it would be a fun thing to go over if we could use those tools to test this database. It's a garbage database, but it would be a fun show off of the tools in theory in the future when it's multi-node. All right, we ran our compaction. Now what we need to do is see if we can get our newest follower. Uh-oh. I don't think our index survived compaction. I don't think our index survived compaction. That's pretty horrifying. Let's look at what compaction did. Wait a second. I don't actually see our thing. All right, so it's in there. It's in there. We have another bug. Wait, didn't Foundation DB get bought by Apple? Was that a different DB? Was that a different DB? I don't know. I'm just clicking on stuff now. I thought it was bought by Apple. Oh, yeah. Right there. Okay. So, yeah. Cool. So, what does Foundation DB use as an index? If I had to guess, I would guess a B tree because I think that's like the most popular because I'm just guessing at this point. Also, what do you guys use for multi-node consistency? So what is your how are you solving the Byzantine? I would love to actually dig into this. If somebody wanted to join me and talk about how they solve different problems on here, I think that would be a fantastic YouTube video. I'd love to dig into how Foundation DB works because we're doing this exploration of deep databases and how they work at like a very base level, starting very basic and moving up. Would love to talk to somebody about how Foundation DB works, why it works the way it does, and what trade-offs you made to do what you did. All right, so our index died in compaction. Compaction just killed it. If you're looking here, it's not even looking through indexes. Yeah, Define Evil, get in touch with me on Discord. It's a great place to. I also have an email I can get you, but I'd get it to you on Discord. So Discord's a great place to get in touch. I would love to do some stuff with you guys. That would be awesome. Absolutely. It'd be fun. My goal is educational content, and those types of things are super educational. All right, so our index died. It got cut down in its prime. Did not work. Did not work. You know what, though? I need to stand up. It's been 2.5 hours. I meant to get up every hour. I'm going to get myself a drink. I'm going to be gone for about 10 minutes. Please don't all leave. But you can leave if you need to. But you should get up, walk around, stand up and something. I'm going to be right back. We're going to put in everybody's favorite animation since we haven't actually got a real animation. So we're going to put in a nice little, we wrote this on stream. This is about the only Python people have ever seen me write. I don't let people know that I can't really write Python. It's kind of a lie. It's pretty terrible. But I am going to be right back. Give me just a second, and we'll see why. We will see why we're killing our index in compaction. All right, I'm back. Wrong one, that one. How's everyone doing? All right. How do I get out of this? Oh, escape. Forgot. All right. Our index is dying. That's what was happening. Our index was dying. All right. Let's remove that. Cool. Our index was dying. We are starting compaction. So let's walk through compaction. So in compaction, we're doing two things. We're deleting old ones, and we delete them with the files, and we add new ones. Did we call the wrong function? Did we do something like really simple stupid where it's like instead of add index, we called delete index or something? So here we're adding index. Oh, interestingly here though, we actually generate the index for the file before we write the data to it. That's probably... We'll come back to this. That's probably not... This is an edge case, basically, if there's some stuff left over. Let's come up here to the main case. All right, let's see. Obviously, this is what makes software engineering fun right here to me when I wrote it. That's exactly what was the thing that made software engineering fun. I do actually enjoy that part right there. Like, it's good. It's good, but I'm glad I put that in a comment. Let's see. Let me step back here. I need to understand what's going on here. All right, we get our current generation. We're going to start iterating over these. This all makes sense. I need to clean up some of it, but iterate over each file in that generation. So we break it down into generations and files, and then we start iterating from the oldest to newest. Makes sense. Here we go. We're creating a new file here. We skip the main log as usual. How are you doing? Let's see, files. We're opening this file for read. We read the lines, and we're inserting them into the set. So this is the list of compacted files. This is our set of records that we can purge to a file. When we get to a certain memory size, this is when we purge that file. Okay, so this is the problem right here. we generate the index before we purge, like before we load the data. This is us loading the data, inserting it. Okay. And we just did not care at all that we built the index off an empty data file. Okay. Is that really it? Is that it? Does that fix our entire problem? If it does, I will feel like such an idiot. All right, let's go ahead and run that. We actually don't need to run it with compaction. Actually, though, interesting, we should re-index when we start. So to test that, we can actually try this right here, and it does get it. So we just proved that indexing at the start works, even on the segments that were built long ago. Okay, cool. That's actually a good test to run. And now our last thing is we need to make compaction run again. So what we're going to do is we're going to run bench, get us a bunch of stuff, and then we're going to run compact. And now we're going to see if our newest follower is still a follower. Oh boy, that didn't fix it for us. All right. So if you see here, watch this. We're going to run get. This is interesting because it's only looking at one index. It's only looking at one index. By that, check this out. When we run bench and we have a bunch of files, remember per log, we have one index. So if we do this, you'll see that it prints out one of these for each file. So we're destroying our index one way or another. Like it doesn't have all of these in it. Our index dies on compaction. So let's check out what we're doing. Here we're 4F in compacted files. So this is looping over every compacted file. We're deleting it. And I do believe we should call remove index, but we don't. I thought we called that here. Did we remove that? We should. We should call remove index. So that would be index. Oh no, it's not on the index. It's on the DB. DB dot remove index for the segment, which is F. Yeah. So we weren't cleaning. I mean, this would just be waste of memory. It would actually be a memory leak if you want to think about it that way. This is if we have extra data left over in memory here. We add the new index when we do the same mistake here. Where we actually index the file before we write the data to the file, which is just brilliant. I don't know why we do the removing the compacted files up here and down here. We also clear them here. I feel like this is just not needed. I mean, I guess this is doing it on each loop. Cleaning up the compacted files. Let's check this remove index. I don't know what's going on. At some point, we're basically just clearing the index. We never call clear on the index, do we? In here, our main index. We never call clear on this thing, do we? That's a read. These are the only two writes. So the only way to clear every index from this would be to clear each and every single one of them, right? What am I missing here? What have I screwed up here? There has to be a different angle to look at this that I'm not looking at. The only place we recall remove is of these compacted files. But if we call compact here, it's going to compact it like it should. It's going to look correct. But if we call a get, you'll notice it only looks through one index, an empty index. Which means at some point we're nuking our entire index. I'm thinking about this wrong somehow. Although it's on compaction. What have I done, people? What have I done? I did something. I screwed something up. All right. One thing that I've screwed up is this function is a disaster of a function. That is for fact. Everybody can state it in chat. It won't hurt my feelings. It's a disastrous function. If you're saying there's a lot of comments, it is designed for people to come see and try to understand what's happening. But it's not even like it's checking a bunch of empty ones. Like even it doesn't have an index per file anymore. It literally is. And the compaction is working, right? We can see that here. And it has the files that we would expect it to have. So this is the compacted file. This is the main log file right now. So compaction is doing what we would expect of it. Line 173. No, I'm removing the compacted files. So this is removing the index for the compacted files. So the files that get compacted and are done, like they're not part of our database anymore, we remove those indexes, yes. You know what, though? We can, to prove that if this is the point or not, we can just comment this out. We can just comment this out. And we'll leave we'll actually even leave the compacted files. We'll just leave them. Actually, let's just remove this point. It will make it very hard to see what's going on if we leave the compacted files. Now, the interesting thing is if we run this, we'll actually get... We'll look over the main index. It's not in the main index, and we found it in the second file in the generation 1. So everything's working fine. We'll do one bench and then one compact. And now we'll do our get the records found. So we found the problem, at least. We found the problem. You called it out. 173 is a problem. Why is it a problem? Because it doesn't even make sense to me because we removed the file. The file doesn't exist anymore. It's gone. It's done. It doesn't exist. But one second. Do I screw this up here? Removes the key from the map, returning the value at the key if the key was previously in the map. The key may be any borrowed form of the map's key type, but hash and equal are on the borrowed form must match those for the key type. Examples. Why would this... Yeah, I don't know what's going on here. But if the... And I don't think so, Russell, because if they were, the files would be getting deleted. There wouldn't be, like, we wouldn't be able to get the value anymore because every file would be being deleted, right? But it is on disk. Like, we have files still with the information, right? But let's try to validate that. Compacted files. So let's validate that. When do we insert into the compacted files? We insert into the compacted files here. And this is after we add the compacted file to our record set. So this path right here is the path of the file that we read into our set. And our set is where we're eliminating, we're replacing older records with newer records. So our set here, so once we've added it to the set, we add it to the compacted files. And once we flush that to disk, so once we've built up a large enough set, we flush it to disk, and then we delete everything in the compacted files. So it would be this new segment name that would be the issue, right? This is the new file we're creating. And this is going to be the current gen +1. And all we're doing here is getting the time since the epoch and the generation. I think we need to do some printing. Yes. Yes. Let's do, can we just do this? Let's do print line files to be deleted. Not at all what I meant to do. Files to be deleted. Compacted files. And then let's, up here, let's print the new segment file. we're just going to print it here. I forgot a semicolon. Okay, so now we run a bench, run bench. We see that we have a bunch of files. We're going to compact them. We're going to see that we delete those files. We actually probably need to do this in a smaller scale, not so many files. So maybe we restart everything. It's a single thread that's generating them, and it's based off the epoch, so they should be unique. Especially because the files they're replacing. So when we do a bench here, those are all based off the epoch, and then when we do the compact, all these are the new ones that are going to be those compacted. Like there's hundreds of seconds. It's not even like it's running close to it, because like now it's compacting those. I honestly don't know. I believe it is because it's using the Linux one. But I'd have to check into the implementation. But there's enough time that passes between the writing in this scenario. I'm not saying that there's not a bug there, Dirk, because you're probably right. That needs to be investigated. If we could possibly do it at the exact same time from the same thread, I don't know. I believe, I actually don't know. I don't know on that one, but that's not a problem here either way, because there's just way too much time. And the fact is they're not getting deleted. So here we go and delete all those files. So if it was named the same, we would actually be deleting the log, and we're not. This is the weird part, is we're not deleting the file, but we seem to be deleting the index for it. If that makes sense. Because if we remove this where we delete the index, the files don't get deleted. Yeah, but I think you're right, Dirk, that there's a possibility, especially if we get a different index and we multi-thread the writing, that you could definitely have we needed a new file, a new log file at the same time that we made a compaction file. In theory, I think there could be an issue there, and we need to have like some singleton or something. We need to deal with that, so that can't be a possibility. It can't be a possibility in this example, but I'm not saying that our architecture doesn't lend itself to having that as an issue in the future. That's a good call. Dirk, are you coming here to preach to us about Haskell? Is that, I feel like this is what you're about to say. I feel like this is a Haskell statement. Please continue though. I'd love to have the argument. It's not an argument, I mean the discussion. I know you are. I know. I actually think it's good discussions anyways, because it's how you learn more. I am not seeing this, right? I'm not seeing these two things. Are you? Is this dead code? Did we just edit dead code somewhere? This is our compactor. But did you see these lines get print out? I didn't. I think I have a bigger bug than I thought. Possibly one that transcends just the work we did on indexes here. How is this even working? Don't you love those where you're like, how did this ever work? How did this ever work? I love it. I love it when like new engineers have that first like they come to you and they're like, I know this is now broken. We have a bug. I don't know how this ever worked. And you're like, yes, been there. All right. I don't think this ever worked. I'm standing by it. Let's write another. I think the only thing that's actually getting is like the actual segment. So we have this Gen 1 in progress. So let's look for that in progress. So we're getting here. Usually when I look at my old work, and that's what we're doing. This is like a couple months old. So we're getting here. We're going through the generations. We have absolutely no other records from here. And this is where we're adding to the compaction. Now, the compaction is working. It's just what we did to add our index. So basically, when we compact, we have to index the new files that are created or create indexes for them. So let's step over this. All right, so we are getting the segment files that are in this generation, which is fine. We're going to sort them unstably, of course. We don't actually, stable and unstable don't affect us because we don't have repeated values. That should be a guarantee that has. And even if it did, even if we did have repeated value, the previous order of the two values doesn't matter to us. So what happens with unstable is if you had two twos as keys, it could reorder which two was first. It also doesn't guarantee that it will reorder. It just possibly could reorder. So that's just something you have to keep in mind. All right, so interesting. We are generating a new Wait, what is this? Oh, we're just building the thing off. So basically, in the previous ones, our generation gets stripped, and so we're adding the generation back on. Just because how we had to keep it up here was that the generation was part of the thing that could be searched on. So we kind of destructured it, and then we're restructuring it here for the file name. So this would be the file plus the generation. We're checking to see if it's part of the main log, because if it's the current main log, we don't want to. The main log isn't part of our compaction because we only do read-only things, and the main log you have to take a write lock on. All right, so then we're going to print the path. I think this is happening. This is happening. So this is our printing out the path of each generation. So in Gen 1, we have one path. In Gen 0, we have one. Okay, so we're printing the thing that we're working on. We read it. We read the file into a buffer. We read it into lines. In the lines, we insert this into our set, which is going to keep. We actually replace it into our set. So this is going to take that data and say, well, we found a newer thing. This is why we go from oldest to newest. Order is important. And we're going to say, well, we found a newer thing, so we're going to replace you with the thing that's more valid, the more recent thing. And then we add it to the compacted files. So at this point, we haven't touched any actual file. We have read in the old file. We have added it to our record, and we're good. Now, at the end of the file, reading all that file in, we say, hey, has it breached our max file size, our max index size? And if our current in-memory set has breached our max file size, we say, let's go ahead and write that out to disk. So we bump our generation. So basically, whatever current generation, if we're in generation 1, the new file has to be generation 2. That's how we keep file data consistency. So we bump our generation for these files. So for any file, the file that we're writing here, we create a new segment name, which is the timestamp plus the generation. Actually, Dirk, now that I think about it, we don't have a problem here, because on compaction, even if the main log wrote a new file at the same time as this, so they had the same timestamp, they wouldn't have the same generation. I'd have to think about it mathematically, whether we could actually prove that there could be a problem with this, but I don't think there is, because the two threads that have those things have to be on different generations, now that I'm thinking it through. Really good question, and I'm not even positive that there's still not a bug with that. Not our current bug, though. Okay, so generation, we generate a file, a segment file name for the new file, which is just this plus the epoch. I keep wanting to say epic. Epoch. Wait, let's validate this. So we get a new start time now, and we're not reusing this. That would be a bug. That would give us the same time each time. So, and then we get the duration from that, and then we use that. Okay, this looks fine. We create the new file. We open it for write. And then we write each line into it. And this is working. We can see this in our, like, we've proven this to work multiple times. This is writing all the files in there. So that's writing. Then we're going to generate a index. Oh, this could still be failing. This generate index is going to try to get a read on it, which it can't, because we have a write out on it already. Actually, the Linux file system we already proved isn't going to stop this. It's not going to stop it. But I'm wondering if it's been flushed. Let's do something. Let's do something here. I feel like write line should be, this macro should be flushing this, but let's see here. Let's see here. Let's have this write go out of scope. So this new file write should fall out of scope now. To ensure that we read not stale data, because we basically read the file again. This is where I was saying like we could actually like keep an index in memory, but this is easier. This is kind of just the lazy way of doing it. We take the segment path, we create a new index, we read it from that path. We read the files in for each line, we build the index. And this works, this function works because this is the same function that we use for building the when we start up, and other times we've proven that the index works. So this function shouldn't be the problem. Once we build it, we add a new index, we clone the name. Again, I'm keeping it simple for people that don't know Rust, so we're not doing with lifetimes and stuff. In the future, we'll make this a little bit better. We clone the string and we pass in the index that we have here. This was never running, right? We never saw this line. We were only seeing this one. Oh, okay. This is valid. If it never got to the max file size, this wouldn't actually run. So we've compacted all these files. Okay, let's keep going. Because I missed a key point here. We've compacted all these files and we haven't hit the max file size. That's what this catches. This says, hey, if we have any data left over, let's generate a new file. So basically we're saving out these chunks, and we haven't had enough to have a chunk. So that's in here. So is this the problem? Is this it's probably in here. We don't write anything. So let's put some print lines in here. Let's put some print lines in here. Also, welcome to the Discord, Define Evil. Welcome to the Discord. A place of many wonders and conversations. It's actually a pretty fan. I love our Discord. I'll say ours because I don't add as much value as you guys do to it. For the most part, it's a pretty cool place to like chat about different topics. And you have people that aren't there just to argue a point. They'll like honestly give their side and opinion and take on it and their experiences on it, which I super love. All right, let's see. Is it here? I think it might be here. Let's go ahead and do our print lines up here that we were doing. I bet you it's this right here. Oh, wait, we already have a deleting old logs. Did we get to that? Did we print that out? Skipping main log, blah, blah, blah. Deleting old logs. Ooh. I'm smelling something. Let's see if this, let's see. I don't think I wrote this. Let's flush that. Let's clear this. Let's run. Let's do a bench. Let's run a compact. All right, now we're writing at least. Now at least we're getting some of the stuff. Now this was a lot to look at. Okay, this actually looks right though. Like it built an index with a bunch of random crap in it, right? And it saved that index file. Save new segment index. Save new segment index, this. Which should be the same as this right here. Yeah, same name. Perfect. This is the index for it. Mim size of gets the size of it. It just returns the size of a pointed to value in bytes. So I'm basically just saying if there's data left in, like we didn't have a clean flush, which is almost always going to true. It's almost exactly like size of t in C, right? I mean, except this takes a reference. I mean, I guess to be fair, not a pointer like C, but I think it's fairly similar. I said exact. It's not exact like anything in C, but I think it's relatively relatively equivalent. So basically this data is the set that we're building. So this is the set of the unique values while we're running the compaction. And basically I'm saying if there's any data left over in it that wasn't flushed to a file. I think honestly this is pretty dumb because I think even an empty list has some data. So I think this will always run because it will never be a size of 0. But I haven't proven that. But I'm pretty sure that this will always run, which is actually fine. We're just going to flush whatever's left over. Okay, so this, though, looks right. The only thing we can do is check that 611. You know what? Let's do this a little bit more sanely. Watch this. Compact. So this is the file, the new segment file, and this is the old one that got deleted. As you can see, it didn't delete the file, the index. So in this thing, in this right here, in the compacted files, we did not have that old one. So this shouldn't be removing this remove index of F. Shouldn't be. But. Oh. Oh dear. You guys want to know something weird? When we when we deleted this, when we did this, it worked. Even though this isn't the one running. Is that true? Is that true? Because I feel like we were talking about this one only. We commented this out and it started working. This one that I'm not even sure was ever running because we never hit max file size. Was it a fluke that it worked? Was it a fluke that it worked? And it wasn't actually this? Okay, one second. I gotta go. Let's see, compact. We're gonna bench. We're gonna do a few more benches. We're going to search for our newest follower, which could be you. Could be you, but it's not. The record's found. It's working. Now we're going to run compact. I don't know what we did, people. I don't know what we did. It's working. I don't... How did this ever not work? How did this... What? Did we change something? Did we... We moved this here. We moved this here, but this was never running. What did we do to fix this? What did we do? We don't run. This doesn't run. And yet it was commenting this out that fixed it. We didn't touch this. We didn't touch this. It's working. I need a moment of silence for this. Well, I don't understand. I don't understand. We had to change something. Now, up here, in the part that does not run, up here, did it ever run? Did it run once? It doesn't run. It doesn't run because how we're handling, so like the benchmarking only does the alphabet and numbers. It never makes a large enough amount of unique data, because remember, when we compact out all the old stale data. It doesn't make it large enough to actually get through this. We have to actually generate at a different size, which we can do that. We can update the CLI to do that. That's not a problem. But the only thing we did was we put these, we wrapped this in a scope, so that we would force the scope to run off with the right line. So we basically forcing the flushing to disk. But we did that on something that doesn't run. we do that on something that does not run. Was this just like a calamity of I didn't actually write something out? Like I didn't save it? Is that? I don't feel like this is the case. But it works flawlessly now. Flawlessly. You want to remove the scope and see? I mean, yes, I want to see. I know it's indented wrong. I do want to see that. This is going to bother me. Let's bench it a little. Get a good number of files in there. Let's make sure we can still get it, and let's compact that sucker. Now let's get... No, it doesn't reproduce it. How did this ever not work? That's what I'm asking myself. I don't remember something else. Was there something else that I did? I tried to test it between each attempted thing. The only thing that I can think of is I went down here and added these two things. I added these prints. But it's a single thread, and we're not generating, like, the name again. So, like, I can't imagine the delay that this caused to be the issue. I mean, we can delete these. Still working. And now we're going to compact it. And now we're going to get... Yeah. Did I change anything else? The strangest part was, oh, guys, this is still commented out. This right here is still commented out. All right, we're going to uncomment that. We're going to write that. Let's jump over here. Not that. Let's stop. Actually, stop. Did I make sure to write this? Yes. All right, cargo run. And then we're going to bench. We're going to get, looks good. We're going to compact. We're going to get, and it's still working. It's still working. The weirdest thing is the first time we got it working, we did that. I'm wondering if there was something else and I didn't save it in one of the files. You know, like, I'm wondering if it was in here or something, and it wasn't actually, like, I didn't flush the buffer. You know, I know we looked at these. These haven't changed, though. We didn't update this. I'm kind of weary to say the problem's fixed, though. I'm trying to think at this point, is there some way that... Ooh. 1 second. 1 second. What if we run it like this, with compaction on? Now, we were forcing compaction, but I'm wondering if the compaction thread being alive was what was causing the problem, because I did it with the compaction thread at one point. Ooh, I think I figured it out. I think we've been barking up the wrong tree this entire time. I think we've been chasing a ghost of Christmas past. All right, we got it. We're going to run compact. It's still working. It's still working. You know, I at least tried. I want to have the problem now so that I can say, like, we fixed it. Like, we very well could have fixed it, but we fixed it with something I don't know and I don't understand. We fixed it by sheer force of will. Sheer force of will. I'm thinking it's this. This is the thing. And I am wondering, this is the compactor thread, and with it on, it randomly calls compaction every 300 seconds. No, we were never up for 300 seconds. Honestly, I don't think this is it. And everything is thread safe anyways. But yeah, it seems like there could be some non-deterministic stuff happening, which is actually what scares me. Because if there's something non-deterministic, that's much worse. If only this was written in Haskell, you know, we wouldn't have to worry about that. All right. But I think this is where next week's Miri and Valgrid will be cool. So Miri and Valgrid look for non-deterministic things. And so I think that's what we'll do next week, is we'll actually just do a whole thing on them. We'll do a stream on using them to find and make our code better. So I'm okay with leaving it here with, we'll do that. I think. Because I think so there's two possibilities. One, it's deterministic as it currently is, and I changed one line that I didn't think would matter that actually made a difference. Like, that was actually causing the bug. And if that's the case, that's great, but it's hard to also prove. The other is that there's a non-deterministic thing happening, and that is terrible. Now, the thing is, I never delete all of the indexes. So I don't even know how that would happen. Like, there's not a call to delete all of them. You'd have to delete each one individually, and it's a hash. So you can't even say go and delete all of them. Like, you'd have to go and know the keys for each one of them. Which actually, right now, nobody even keeps those keys in memory. We could keep them in memory. We could keep a list of all of our files in memory, but we just read them all off disk. So, like, I don't see that happening, honestly, which is why this caused me pause in the first place. Yeah. Yep. I think this is a good job for Miri. Because it seems hard to reproduce at this point. We could also write some sort of integration test that tries to like just repeatedly do stuff and hammer the database with this type of information. I think that would be a decent option as well. All right. Well, I think, assuming we actually fix that, I'm not going to assume that, but I'm going to say for the time being, this is a pretty good place for the database. Now, I had some other plans for today. This took a little bit longer than I expected. It always takes longer than I expect. I should always expect more time. I wanted to try to write a Kubernetes operator in Rust, and I'll show you why. I'll show you why I want to write a Kubernetes operator in Rust. One, to do it in Rust because it's fun. And all my other editing and stuff is in Go, and I don't like being predictable. Git rm okay, yeah, we should not be checking in segment files. That's horrifying. Do we have a, let's see, do we have a let's see, we want to ignore basically we want to ignore all segment files. Added compaction support to indexes. All right, Russell, are you still on, Russell? Are you still on? I have something cool to show you, if you are. I think everyone could appreciate this. Russell's seen a lot of it. All right. I worked not on stream last week. I didn't really feel energized to do it. It takes a lot of energy for me to do some of the stuff on stream, and I really wasn't feeling it last week. Was kind of I had a rough week, but I was super productive because I was not in a good mood and programming. So that's like perfect time to just bust some stuff out. Got KPAC support in Eddington. I have it all working for the most part. Well, there's actually one bug, but it's okay. And I wanted to make a Rust operator that would actually watch for this one custom resource. So you're about to see it, and I want to show you why I want to make an operator. Now, I know that you can make an operator with Rust. What I don't know if you can easily watch other people's custom resources that were written in Go. So that's what we're going to have to figure out. And I think that will be kind of fun. So code, wow. We'll jump over. Actually, we don't even really need to be here. What we'll do is K9S. We'll open up our Kubernetes cluster. That's the wrong cluster. You can actually switch contacts in here. All right. So let's actually clean this up. We're going to delete that. Not what I said to do. Delete. Yes. Now, this is a live test. So give me credit if it doesn't work. Live demo on something I just kind of figured out. We'll see if it works, but it should all right. So deploy. The one thing I don't have is there's no cleanup itself. Like it doesn't go through and clean up the its mess. It doesn't do that yet. All right, so we're going to open up Postman here, and we're going to create a new user as usual. Okay, we're not going to create. Let's see if it's up and running. Oh, it saw our kind it was on the wrong cluster. There we go. All right, it's up and running. Cool beans. So now we should be able to add our user. Worked. Perfect. Now, this is a call with a Git repo and a directory of Go and a name. We'll name it something different. Test delete me. Okay, so a name and just a Git repo. That's it. If we want to look at this Git repo, we can look at this Git repo to prove that there's no like container or anything else in there. It's literally just a blank, or not blank. It has a Go application. In here, it just has a Go, Go mod and a main.go. And all this has is a literal Pong server that just pongs back on the port that it's listening to. That's it. So we're going to send this request to Eddington. Fingers crossed. We're going to see some chugging happening here. But the cooler thing, we can come over here and we can go images. And give it a second. Uh-oh. Uh-oh. Well, oh, there we go. There we go. So you can see that this image got built right here. We can actually look at it and we can see which repository it was building. So it was building the null clouds example. It was building the subpath of Go. It's looking at the main branch. Cool. But it doesn't stop here. No, it doesn't. We also can look at our services And you'll notice that we have a default 123 default. This is my namespacing. It's segregated by namespace per user, and this user's is this is their namespace, but they have a test delete me service. That's literally this. The test delete me is the name of the application, and they have a service for it. They have a virtual service. They have a virtual service here with the test delete me. We can look at this, and if you look at it, it actually routes us through the data plane of the Null Cloud's gateway. So when I get this deployed, it's actually going to expose it through the internet at nullcloud.io/dataplane/the customer ID / the name of the application. That's where it will be exposed to the internet. We have a deployment here. So you can see here, this is the deployment that's powering it. Now, this is the bug. You'll see that it's not ready, and it's not ready because some dum-dum copied the container image wrong. So the name isn't, that's not a valid image name. That's a bug. The image does get created. We can go back to that image. We'll go here and look at this. And by the way, I'm starting to love K9s. I am absolutely loving it. We can actually go and take this Null Cloud image here. So let's copy that and jump into another terminal somewhere. We'll just jump here. This will be fine. And we can just do Docker pull. And we can prove that it's actually the Pong server and use it. It is. But you can see it's actually a container image that was built through all of this. Yeah, I'm pretty stoked. Now, why do I need a Rust operator? Well, I don't need a Rust operator, but I do need an operator. And one of the reasons is this right here will now build off of the main branch. It will always this is always going to build off of the main branch because that's what we set it up. We set it up to build off the main branch. Now, the thing is that when that happens, it doesn't notify me. There's no notification. So what I want to do is I want to build an operator that watches these image custom resource definition and basically makes an API call. In the future, it should be like an event using nats.io or Kafka. For right now, it's just going to call the monolith that handles all that. And that says there's a new build of this thing. And so we can re-update the deployment and things like that that are doing it. But I mean, it works for the first deployment. As long as you don't want to update your application, everything works. I'm super excited. Like, I don't know. I thought it was going to take more to implement Kpack than it ended up needing, which I was happy about. Now, there is the ability for the null operator to handle this. The null operator could also watch, and we'll probably do that next week. But what I wanted to do this week was just see how easy this would be to do in a Rust operator. So I thought that we would try that. It's all sitting there kind of working, so we can just try it. Thanks, Russell. I want to make a video about it. I just haven't gotten to it yet, and I haven't felt like I had something that I could show off, really. We've done stuff, but doing stuff is a little different than doing something somebody could see the effect of. I feel like that's a better YouTube video than like, hey, look, I did stuff, but can't really see the effect of it. And we're going to make a dir for, we have the null operator, but we're going to make a image watching, a build watcher. Now, again, the null operator could also be the build watcher, and possibly that's the right path to do. But I'd like to see how hard it would be to make a Rust operator. We're going to use this project over here, CubeRS, I believe is what it's called. Yep, CubeRS. Cool beans. Let's go to there. Ooh. Oh, they have a dark mode themselves. Nice. All right, getting started. Let's do it. All right, so with CubeRS, they have their own way to make. Now, we don't actually want to create our own custom resource. We want to create an operator, but not a custom resource. We're really just wanting to watch another one. And this is where I'm not sure if it's going to be easy to do, because if you look through what I was seeing is like, oh, look, they do stuff with the pods API, but like they have a strongly typed thing. I think what I have to do is create this image one. So if we look at this, images, this is a type. And basically, I just want to get this. Now, what I'd like to be able to do is not have it strongly typed. I'd like to just get it in JSON. And I'd like to query it by its version, kind, and name. Like that's what I'd like to get it by. And so in Go, you can do this. I don't know if CubeRS has that ability. It's not the stuff that people talk about a lot. But yes, that's what we're going to. Writing a cube scheduler in Rust, operator, oxidizing the cube. Oh, this is with the finalizer and state machines. We'll have to go over that. One way or another, whether it's for Eddington or not, we're going to write a Rust operator for funds. I'm not sure what it will do, but that's what we got to do. Hidden generics in Kubernetes API. Oh, I'm going to watch that. That's an interesting one. So to write an operator, you got to watch your own custom resource. So let's see how they do that here. Let's see. Okay, so yeah, that's what they're doing here, JSON. Oh, perfect. This is exactly what we want. You know, this is the group version. So they're doing group and version together. Man, that's fine. Kubernetes is a lot of duck typing. That hurts my soul. I mean, it's a lot of requests. When you think about it, the Kubernetes API is just a REST API. It's just a REST API with JSON. A lot of people use YAML, and like the kubectl command line converts that YAML to JSON and sends it to the server. Like that's really what it is. It's not really duck typing. I wouldn't consider a server duck typing. There's an actual strong Go struct that backs that type. Just whether do we want to re-implement that type in Kubernetes or into Rust? I don't want to do that whole type, because if you're looking at it, I just need this latest image. I need to know that there was a new build and what that latest image was. But yes, it can kind of feel a little bit like duck typing. I get the sentiment. We don't think of Kubernetes as a microservice itself, but that's really what it is. The architecture of it, you have a bunch of different components that all do their own thing. And the API server is kind of the thing that ties everything together. And it has a database, etcd, and it just kind of it ties all the pieces together, which then makes it feel that way. So I get the sentiment. I'm not sure I 100% agree, but I get it feels a lot like it. Yeah, for sure. So this is our group, kpack.io. This is our version, and our kind is image. Okay, so we're creating a... Oh man, naming this is difficult. It's not really the null operator. It's like the null watcher. I'm going to put RS on there just so that if anybody stumbles into it, they can stumble out of it. All right. Cool. This is where the tutorial starts. In the section that follow, we'll be creating an operator with an API service. We'll use Rust. All right. First, clone our example repository. This is what I've seen is, unlike the other one, there's actually a lot of just like clone the repository and start with that. Do you know what we should do? We're just going to clone this into null watchers RS. Done. Now I'm going to remove Git. There we go. All right. Oh no. Oh no. What have they done here? Note that the example directory is divided into 3 steps, each with a pre-built image. You know what? Maybe this is all good for its own stream. I feel like the Kubernetes operator in Rust is its own stream. That's what I'm feeling. I'm feeling like we did good. We've done a stream. And I need to investigate this a little bit. I want to have it a little bit more doing the thing instead of like, oh, I don't know how to do the thing. Yep. Also, I'm 100% almost positive that in Eddington we do it in the null operator and we just keep it all in one operator. We could make the null operator right now is super duper simple, and we could make it in Rust instead. That was kind of my thought. Like, if this goes well, this watcher goes well, maybe we convert the operator to be Rust, so that at least a small portion of the thing is performant. I'll have to think on that. All right. Well, this week, expect to see a few. They won't have my voice with them, but expect to have a few things in Discord, going over the database video. I'm looking to just do some of the explainer segments, and I'll have like the text that's going, like, this is demonstrating this. So I'd like to see those. Maybe when it gets closer to the time of the video, it's going to take me a couple of weeks to make the video. I'll have them with the voiceover as well. I'll just make the videos of the thing, because I'd like to learn to make this like a really good video, like a really high quality video. So I'm working on it. So I'll get your guys' feedback if you guys don't mind. Don't forget to fix I'm going to fix the alerts. I forgot that the alerts are broken because I don't have the key in. So that's all I have to do is put in the new key to rotate the key. So I will do that. Actually, right after I end the stream. There's nothing fun to see there. It's literally just it needs the key because we created a new deployment. So that deployment needs the key. So nothing to really actually show, but I will fix the alerts for tomorrow. Now, tomorrow's news section. The guy didn't respond to me yesterday, but I have a person that has done something interesting as of yesterday. I mean, they've done something interesting, and hopefully they'll be on the news section with me. I'm not making any posts because like he didn't confirm yesterday. He confirmed earlier in the week, but he didn't confirm yesterday. I was hoping that he would confirm yesterday. So hopefully he shows up and we get to have a conversation. I will tweet about it. Just as long as he's confirmed. We're going to be starting at 4:30, so actually half an hour late compared to normal. Usually I'm at least 15 minutes late, so it's not that much later. But hopefully we have a guest speaker on to start the news out for us, to go over a piece of new... we actually lightly talked about it last week, but this is a person that's been involved with it, so hopefully they show up. I'd be really excited that you know, they accepted, so I'm very excited about it, so that will be fun. Yeah, well, so I was going, like, if they confirmed yesterday, I was going to make like several posts on LinkedIn and stuff for it, but since they didn't, I was like, I don't want to... I mean, they confirmed earlier in the week, but you never know. I don't know the person personally, so like I don't have like their number to be like, hey, are you know, everything okay? I don't know. Something could have happened. Lots of stuff going on in the world, so I also don't want to make them feel bad if they have forgotten and they missed it for some reason. I will still try to get them on later if they miss it. But yeah, I didn't want to make them feel bad if they for some reason forgot and missed it. I know that I'm not that important, so it might be easy for them to forget, but hopefully they don't, and hopefully it's a surprise. Hopefully we have a really good conversation that's really educational on the topic of some of the news, something that I pointed out people had a lot of confusion about last week, and hopefully we're going to help shed some light on the confusion. So yeah, I'm pretty excited about it. Anyways, I hope you guys have a fantastic week. I hope to see you guys tomorrow with a guest, and I will get my alerts fixed by then, even though for the conversation with them, we'll probably have them turned off. So, all right. And let me know what you think about the... I hope to do more educational content like these indexes and stuff in the future. So we'll get it rolling. Thanks everybody for your time, your effort. Thanks for helping me with the indexes today, and I will see you guys hopefully tomorrow.